Okay, can you see my screen?
Yes, thanks, we can see it.
Okay, great. I'll get started then. Well, first of all, a big thanks to everyone attending and the meetup's organizers. I'm very happy that this can still go on and we're able to host this meeting virtually. A little bit about me to get started. Today is actually my first year anniversary at company Ferrum Health. I'm happy to spend it with you. I work there as a head of partnerships and machine learning operations engineer. I've been a Go developer since 2014, so that's like a little bit over 6 years now. I also code mostly in Python for machine learning stuff and TypeScript for front-end related projects. Two links, one to my GitHub where this presentation is hosted, as well as the code that I'm going to go over. I'm a bit ashamed of the amount of open source work that I've done in the past few years, so don't judge me on that. And then my LinkedIn. Okay, so what are we going to talk about? We're going to talk about mocking external services with Go interfaces. Why? So I hope that at the end of this talk, you can have a few takeaways. So instead of having, let's say that you start a new project, you start a new Go app. Instead of having testing, which is usually the case as a nice to have, an afterthought, how do you ensure that you put testing at the center of the development of your next project? I'd like to share an approach that worked for me in a few recent, fairly complex projects that involved a lot of different moving parts, and see how and why mocking was involved and was useful. The goal is for you to have some sort of framework which still allows for rapid prototyping while embracing test-driven development. We'll dive into what that means, and still ensure a quick feedback loop on the evolution of your project. Ideally, you can isolate and you can separate in your app the core business logic from the external world and the interactions that you don't control. You can be aware of what you can control and manage expectations on what you cannot. And ideally, if that works well for you, you can reuse that framework, that mental map in your next project. Testing. If you look at the software testing page on Wikipedia, which is actually quite good, you see that there's a lot of different levels and techniques and processes around testing. The first one that is underlined, unit testing, is probably the one that you have most heard about. Dave Cheney, famous Gopher, describes what is not a unit test. Basically, it's something that does not involve external services, that then does not involve a relationship with the external world, doesn't talk to a database. Well, it's not a unit test if it talks to a database, if it communicates across the network, touches the file system. So, we want to have tests, but that also represent the what our app does. But unit tests, which are the most prevalent and common tests, should not be interacting with external services. So how do we kind of find a compromise between those two? You have different levels of testing, not just unit testing. You have also integration and system testing, which integration would be testing the interfaces between components, where system testing would be an end-to-end testing of an integrated system. Techniques, like how do you actually test it? And what do you actually test? Smoke and sanity testing would be just testing the basics, the first level, that your app kind of works as expected on a very basic level. Destructive testing would be just take down one of the components of your app, see how it behaves. Concurrent testing, Go gives us a lot of very good primitives for concurrency. How do we test that? How do we test that the things our app does happen in the order that we want them to when they're happening concurrently? We'll talk about that as well. And then, the process that I mentioned early on, test-driven development. Test-driven development is kind of a method to integrate test as like a first-class citizen of the way you write code. You essentially write code, you write tests first, and then it looks like this. I took this from ThoughtWorks, the link is below. You write a failing test, You make it pass by writing code, and then you refactor, and then you keep iterating. But the first thing you do, almost one of the first things, is write a failing test. So that's not necessarily the way, everyone works right away. That's not the most intuitive thing. So, how do we propose a framework to integrate that into our workflow? For that, a few more theory, a bit more theory before we dive into actually some code and some examples. I think a useful mental model for building an app is thinking about it in three types of large components. The first one at the top is the core business logic. You control that end to end. You wrote that code, or someone in your team wrote that code. It's all contained. You should be able to test the behavior of everything that's in there. That's where a lot of the unit tests will live. Then you have internal services. You control the configuration. You don't control how they're written, but you control how you configure them because you spin them up. These are things like your databases or message queues. And then the third one would be external services, for which you have even less control over. Think about it as like third-party APIs that you have credentials for, you can interact with, but if they're down, they're down. There's nothing you can do about it aside from filing a ticket. So how do you ensure that your app handles behavior from those things that you don't have control over? One more definition, Go interfaces. Mentioned it at the top, just want to make sure everyone is on the same page. An interface is sort of like, can be thought as a contract between services. You don't have to know, like if I'm going to use your service and you give me a Go interface, I know essentially how I can use it. I don't necessarily know how it's implemented behind the scenes. If we look at this snippet here, this example, a task runner. So something that can run a task here on a GPU. The things that might be useful for you is to list the pending jobs, know if a GPU is available, run a given job. That's kind of all you need to know to make that task runner useful for you. And there might be multiple implementations of that. Because an interface is just sort of like a contract, but there are multiple implementations that can be for the same interface. It's quite handy when it comes to mocking. And we'll see how these two ideas play together quite well. All right, so to illustrate those ideas, let's build an app together. What does the app do? Try to stay as simple as possible while being somewhat real-worldish. We're going to do two things. We're going to periodically scrap the Hacker News homepage to look for articles about the Go language. And then once we've got articles about Go, we're going to try to store them in a database. So let's look back at that mental. Well, first of all, if you're not aware of what Hacker News is, it's a website that lists a bunch of like tech or dev related articles that gets updated very frequently, a few times throughout the day. The way we would scrape that website, for instance, would be just to load that homepage, parse the HTML code, look for specific links that would mention Go in the title, and then store the link as well as the title in our database. So back to the mental model that I talked about earlier. Here, what do we have? If we are going to build that app, we have something that we have control over, which is the app boundary. Our new Go, what does the logic look like? We do really two things. We check in Hacker News if new Go articles are available. If yes, then we store them in our database. So there's the logic here, and then there is the interaction with one is external components that I have no control over. If Hacker News is down, if the website doesn't exist, I just can't use it anymore. And then here, my database, we didn't write Postgres, but we can use it, we can configure it, we can make sure it's highly available, things like that. So we have configuration control over. So let's write some code. Let's try to implement this with a test-driven approach. First of all, system architecture as well as but code layout. So that's not a necessarily a standard in the Go community, just like a way I typically like to do things like that. I like to prefix the app, the external components, and then each services with sort of like their name. So app.go and app test, everything starting by app would be prefixed by app. External components would be prefixed by their name. Here, Hacker News tests. And then you can see for those external pieces that I added a mock.go. And we'll see how and why we need that. Well, I guess that's the purpose of the talk, is talk about mocking, but like, how can I test my app while relying on external services and have unit tests that essentially test the end-to-end behavior of my app without really having to have those services up. Yeah, so before that, now I'm going to dive, I hope this is not going to be too overwhelming, but we're going to dive into like what the code actually looks like, because I think it's pretty simple. So I'll just go over this bit first. We'll go over the app boundary. So test-driven development, the goal is to get to writing the first test as quickly as possible. I think it's not necessarily realistic to write that test first, but what I propose is that first we write some core logic relying on mock interfaces. We write a test, and then we write implementations for those services. And so that's what we'll go over. So what does it look like? If we look at the app, well, the external interfaces that we need are twofold. One, for Hacker News, the only thing we really needed to do is to be able to get us the latest articles. And for the database connector, it just needs to be able to store articles in it. So, the concept of interfaces here is nice because it allows us to focus on what we care about specifically for our app. Of course, connecting to a database should be able to give us way more power than just storing articles. And having access to the Hacker News webpage should also be able to give us more than just listing those articles. But that's the only thing we care about. And that's what we'll implement as an interface here. And then the app is the thing that ties everything together. It's the glue. So it has a connection to Hacker News and it has a connection to the database. So if we look at the core logic, again, that's a pretty simple example. For loop that sleeps every 10 minutes, we're going to get the latest articles, return an error if that didn't work, log this, and if we got articles, just store them in there. That's as simple as that. Okay, so now we've written some basically core logic. We've put the pieces together without having an actual implementation for the external services, but that's not needed yet. So we'll look at an end-to-end test. And that's, test-driven development. We want to get to that as soon as possible. We're already there. What would the end-to-end test look like? Well, let's take, for instance, two fake articles, feed them into the app, feed them into Hacker News. So we have a fake Hacker News. We run the app in the background, and then we essentially here have something that waits for those articles to be in there. So what that test does is two things. One, we have something that mimics the behavior of Hacker News. So it mimics inserting data in a fake Hacker News. And the second is something that is our app. Our app will scrap Hacker News and store it in a database. And so at this point, I've written this test. All it takes as input is not actual implementations. I do not have an implementation at this point of what the scraper for Hacker News will look like. I do not have an implementation of what connecting to database will look like. I simply have an interface of what I want those contracts to be. And that test passes because it takes interfaces as, that takes compiles because it takes interfaces as inputs. So what have we done so far? We've got an app that's wired up. We've got an end-to-end test written. We just can't run it yet because I cannot sub my interfaces with actual implementations, which would be needed to run that test. And so that's what we're going to work on now. We're going to look at a mock implementation of those interfaces. Extra goals for those, we want to test two things: reaction to failure. Let's say one of those services fails intermittently, and then we want to test concurrence. So let's implement those interfaces. For those two extra goals, I typically add the two utilities that we're going to review right now. No, not yet. That's slide after. So first, just going back, we've done this part. We've done this part, and now we're going to look at this part, specifically the mock. So the thing I just mentioned is we want to mimic real-world behavior with a simplified version of it, which we have control over. And so in the real world, if the Hacker News website is overloaded, it's going to take not 200 milliseconds, but let's say 5 seconds to respond. We don't want our app to depend on that. So we have something like a waiter, which can wait as long as we want. So we can test how our app would behave when the Hacker News website takes too long to respond. And then what if that website is down? What if the connection doesn't work? What if even our Wi-Fi doesn't work? Well, in Go here, an error would be thrown. So we want to see what our app does when an error happens. And see here, you can have an implementation of something to a failure that fails. And you can control how you want it to fail. Maybe you want it to fail at a certain rate. Maybe 1 in 10, you want it to fail and see how your app behaves. Maybe you want it to fail 90% of the time. So you can control that here. And now we'll finally look at a mock implementation of those interfaces and how they use those two things. Hacker News mock. Nothing super eventful here, and I just want to focus on that part. We have a Hacker News mock structure, which should implement the interfaces that we had, the Hacker News scraper. The first thing that we do in the guest latest articles, which is the one function, the one method that should be implemented, is we wait, what I just mentioned, and then we fail. If it fails, well, we return early. Otherwise, here's the implementation. Nothing fancy. There is a lock because we might be accessing that concurrently, but you can essentially just think of that as a simple map that would store articles. And that would be our Hacker News fake web page. On the flip side here, something that is not needed for production system, but is needed for testing, would be something that feeds the fake Hacker News. And so that's something that essentially populates that map. It's not needed for production, it's needed just for testing. And now we can finally wire everything together and feed that mock Hacker News, a mock database that I didn't show, but you can check out the code. With that app, so you can see that the app, the only thing that it takes as input is that mock implementation of Hacker News scraper, mock implementation of a database, and then you can just run an end-to-end test on it. And so then you're really like test-driven, if I may. You have already written some code that works, and in fact, the test passes. So now you have a test that passes. The only thing that you have not done is implementing the external parts of your system. But you don't have to wait. The advantage of this approach is you don't have to wait for your entire system to be written, for end-to-end tests to happen. You can mock, you can essentially put fake versions of those external services while still focusing on writing your core logic, and then essentially writing this end-to-end test, and then later on subbing each of those parts and then making sure that your tests keep passing over time. In terms of the testing spectrum, we have unit tests that are typically in memory, focusing on the core logic, such as functions that would say, what is a Go article? Is it something that has Go in the title? Is that enough? You want to be able to test for that. But unit tests do not depend on external state. While on the other end of the spectrum, you have end-to-end tests that look at your app behavior given some input, what is the output that you'll see at the very end. It might take time, it might rely on external services. And if you want end-to-end tests to happen in a unit test fashion, meaning to run often, maybe run every time you compile, and that's when you introduce mocking, as we've just seen. Cool. All right, so let's recap what we've done, and hopefully a few takeaways that you can have. What did we accomplish? We've gotten a mental model of what an app logic in the broad can look like. We built a quick working prototype. Probably in a few hours, you can get that mental model if the app is kind of as simple as that, and the definitions of the interfaces that you can play with, and then start playing with it. You have a tests first approach. We've not written that much code, but almost half of it is tests that can be, if it's not, if you don't exaggerate, if you don't spend your entire time writing tests without writing any code, there's a compromise to be found there. That is typically a good sign. And then what we've done is we've mocked external components and passed the tests. And then from there, what do we do? Well, we implement the actual connectors, we implement the actual scraper, we compare the mock behavior versus the real world implementation. Maybe these first interfaces were not actually realistic. Maybe the way we're going to scrape that website is going to behave differently. For instance, I didn't talk about pagination. I didn't talk about how many of, what is the definition of a Go article, things like that, that while it's useful to have mock interfaces, abstract representations of what it looks like to scrape the Hacker News website, when you actually do it, you'll very quickly have to iterate on the initial definition that you have set at the beginning, which is fine. That's typically how you should process. You should write something small that works, break it, challenge it, iterate, and keep going. That's it for the hopefully framework that you can have in mind. I have some resources for you if you're interested in more testing and mocking. There are some popular tools for you for testing and mocking in Go. There is the Mockery, there is the official Golang mock. For testing, I think that just the standard library is great, but if you want a bit more, Testify is pretty good. Resources that I've used here, ThoughtWorks about test-driven development, and a blog post specifically about mocking Go interfaces in real life. And then Wikipedia had pretty good articles about the test-driven development approach and software testing in general, very, very long and extensive articles. That's it for me. Thank you very much. I've uploaded the code and the slides in that repository. Feel free to reach out. Shameless plug. We're hiring senior Go engineers at Ferrum. So if you want to talk about it, let me know. Thank you.